9.3 is estimating a population standard deviation, and so to avoid negative and positive values being involved, we consider instead the sample variance and the population variance. And so recall that the sample variance would be S squared, and the sample variance would estimate the population variance, which is sigma squared. So you can always evaluate between variance and standard deviation by squaring or taking the square root, just depending on which one you're trying to find, what order you're trying to go in. Okay, so we are going to estimate the population standard deviation using a new distribution. It's called the chi-square distribution. It's pronounced chi, and it looks like this. It's pretty much just an X. It's a little extra curvy because it's a Greek letter. You can Google chi, the Greek letter, and you can see how to form it. But really, I just make the first part of my X curvy and the other part not, and that's chi. So it says see page 456 for more details on the chi-square distribution, but the key features that we care about are that it's not symmetric. If you look at it, will depend on the degree of freedom. That's what number 2 says. So it could look different, but it will never look symmetric. It'll get more symmetric. It talked about getting there, but it's not, or looking more symmetric. And then the values are non-negative. So notice that it never goes less than 0. So we will kind of use the chi-square distribution, but mostly just use it to do what we're trying to do. We just need to be familiar enough with the chi-square distribution. So I have pulled up something that I posted on your Google Classroom, which is the chi-square distribution chart. So we will use it to find different critical values on the chi-square. So example 1 says find the critical values that separate the middle 90% of the chi-square distribution from the 5% area in each tail, assuming 15 degrees of freedom. Okay, so general picture, the chi-square distribution in general has one of these shapes, right? So it kind of curves at the beginning and then it mellows out, or you could say it's skewed. That's probably not a great picture, but it's going to be good enough for what I'm going to do, which is try and decide. I want the middle 90%. So I want to know this area in the middle is 0.9, right? This middle 90%. So when I talk about the area in the left tail is 0.05, and the area in the right tail is also 0.05, the 5% in each tail. So when I will use 15 degrees of freedom to try and find these critical values, let's see what we're working with here. So they in the chart deal with area to the right of the critical value. So when I look at this critical value, I'll make it the red critical value. The area to the right is 0.05. So the area to the right of 0.05 is 0.05, and the 15 degrees of freedom, that critical value is 24.996. And then what color should I use for the next one? Let's do blue. So this critical value, the area to the right is actually this 0.9 and this 0.05. So the area to the right of this critical value is 0.95. So I'm going to use the chart still with 15 degrees of freedom, where the area to the right is 0.95, and I get 7.261. So when they say what two values separate the middle 50%, it would be, I guess maybe I should say, 7.261 and 24.996. So just reading the chi-squared distribution chart, similar to the other ones, mainly different just because of the shape. It's not symmetric.